Hello everyone. Welcome to day 6 of DevOps Complete Course video, DevOps Complete Course playlist, wherein in today's session I'm going to talk about Linux operating system and shell scripting. So in case if someone has joined in day 6 session, today's session only, and did not watch day 1 to day 5 session, I insist go ahead and watch day 1 and day 1 to day 5 session also, because that will give ample amount of information on what DevOps is and how to pursue DevOps course and what are the important things which you need to know while you are learning DevOps course. And also, if you think as if these courses are beneficial for you and could be beneficial for someone else also, kindly share these videos to others too, so that they can also get advantage. And also, if you did not subscribe yet, kindly subscribe so that we both can grow together on it. Okay, so let's begin in our day 6 session. In our today's session, I'm going to talk about what is operating system to begin with. So first thing which I'll be discussing about is what is operating system, and then I'll talk about life cycle of OS communication, which is very much important. Slowly I'll explain you why OS communication and what actually you mean by OS communication and why it's essential. You will get to know in few minutes itself. And why Linux is such a popular thing, you will get to know that also, because there are multiple operating system. I'm pretty much sure that you have used Windows, Mac, but Linux is capturing almost 80 to 90% of market at this point of time when we talk about industry-wide deployment. Why? We'll get to know about this. What are the different distribution Linux? What are open source? What are the paid versions? We'll talk about that also. And I'll give you some basic information about Linux architecture, some basics on this, because Linux architecture is very big, very vast. In 2 or 3 days also, if you're spending time, it will be less to completely understand Linux architecture. But I'll give you crux of it so that you get to know about what Linux architecture is. And then we'll get to know about fundamentals of shell scripting. So today basically I'll explain about some basic shell commands, but gradually in my upcoming sessions I'll talk about more about other things of shell scripting. Okay, so let's begin. First thing is, I'll start with a very basic example. Consider that you went to a market and purchased a laptop. There are many laptop vendors. HP is there, Dell is there, your Lenovo is there, Asus is there. Multiple laptop vendors are there, and you went to purchase a laptop. What you are getting? You are getting a fancy monitor or fancy screen. You are getting a fancy keyboard, your mouse, and lots of input-output peripheral devices you are getting. But what is there within it? These all are the external cases. What is there within it? There is some CPU. There is central processing unit which is inside your body of the inside the chassis of the your laptop. RAM, your hard disk, your input output devices, and all. So these things are primarily called the hardware which is present in your machine, which is present in your laptop. And quite the same thing is true for any other server. You think about any server which is present in this universe, the hardware component of the service will comprise of CPU, RAM, and IO only. Second thing, next thing, what happens when you purchase the laptop and you want to play a video there? What you will do? You will install a software. What that software is doing? Software is allowing you to play that video, but where the video is present? Is the video is actually present in the software? No. The video is actually present in the hardware only, in the memory of your laptop only. There should be something which is channelizing, which is creating a medium, so that when you pass the instruction to software to play the video, it reaches out to memory and plays that specific video only. There can be hundreds of videos, but which video to play, how that can be processed, there should be some medium in between, and that medium is only called operating system. So now, you being a kind of laptop user, maybe a gaming person and plays gaming a lot, or you being a DevOps person must be installing a number of softwares like Jenkins, like Ansible, Git, and others, or you being an application team member or application developer would like to install some programming softwares like Java, like Python, which is pretty much important for you to write any application programming code. Now, for these softwares to interpret, to interact with hardware, something comes in between, to which we call as operating system. So in simple words, if I have to define what is operating system in very simple words, I'll say operating system acts as a bridge between software and hardware. It acts as a medium between software and hardware. That's it. nothing other than that. Now, how this basically functions, what happens basically, I'll come back to that slide once again. You consider that you are, when you are using a laptop, what you are a user, right? You being a user, you are trying to access some application, right? You are trying to access some application. Now, that application in turn is accessing some hardware. What those hardware is going to be? Those hardware is going to be RAM, it's going to be CPU, it's going to be input output devices. Now, the application should interact with your hardware components. What requires in between? Operating system requires in between. So how, what is the flow? The flow is user is trying to access the application will pass the information to OS that hey, user is trying to access that application, and this operating system will take that information to your RAM, CPU, or input output. Now, what RAM system, CPU, or input output will do? RAM system, which is the hardware component, will pass the information back to operating system. Operating system will take that information to application. Application will take that information back to users, and users will be able to access it. So this is the entire flow of information from user to the hardware, and lots of things comes in between. Now, if I talk about operating system, then I'm pretty much sure that from very beginning, from your childhood, of very usually used operating system which you are using is Windows operating system. Why we are using Windows operating system? Because this is having a well-defined graphical interface. Well-defined graphical interface, and we are used to that interface basically. Isn't it? We are used to those fancy interfaces. That is the reason we like using Windows. But you, Windows being a personal, for personal use is good. Windows, if you talk about using in enterprise level or organization, that's not a good practice. I'm not saying that Windows is not in use in enterprise level, but its use is very, very less. More widely used operating system in organization is Linux, which captures 80 to 85% of entire operating system usage in industry. And the in Linux, why we use Linux? There is a specific reason. It's not as in we simply prefer Linux to be used by industries. There is a specific reason. What is the reason? The reason behind usage of Linux is, the first thing is Linux is open source. It's open source. It's absolutely free in use. In case if you want to use it, there are a number of distribution in Linux which is open source. Like Linux comes with various distributions like CentOS, Ubuntu, Fedora, Debian, Red Hat. Many are the open source one. Red Hat though is a licensed version, but CentOS and Ubuntu are the open source like distributions like CentOS and Ubuntu are open source distribution of Linux. What are the another reasons? Second reason, and which is also very, very important reason, is this is very secure. This is very secure because you must be hosting some confidential data on the application. You must be sharing your banking details, you must be sharing your perhaps Aadhaar card details or some secret information, some confidential information over website. Now these websites are hosted, or these applications are hosted on Linux machine, and Linux machine ensures that that level of security is maintained so that no external breaches can happen. That is another very, very important reason. Third very, very important reason is performance. Very, very important reason is performance, right? But very important reason which is which is brought in by is performance. Because of this performance, what happens? The speed, the response time of these all applications is very good. You don't prefer to access or use any application whose response time is very high. Think about, you're clicking on any application and it's taking minutes for it to open. Will you prefer to use such application? Certainly not. So it's providing good performance. Also speed is also very high. Nowadays applications are multi-threaded application, they are very complicated application. Having good response time to such application is very important. So these are a couple of very, very important reasons because of which Linux become such famous. Linux become such important thing in such important operating system to be used in industries now. So these are the important reasons. Another type of operating system which comes with Apple laptop is Mac also, but Linux still being favorite of enterprise level organization because it comes with multiple distributions, it's very secure, it's fast, its response time is very good, and it's also open source. What else you need? It's free, it's fast, and it's secure. That's what you need for any application to be hosted, right? So this is about operating system. This is why you want, what is operating system, why you need an operating system to channelize your communication, you need an operating system, and what makes Linux operating system such famous. Another important thing which I wanted to talk about is architecture of Linux operating system. Very, very important thing. Architecture of any operating system in that context, but I'll more preferably talk about Linux, and I'll go into crux. I won't go into much of the detail because detailing of architecture is sometimes very boring also, and it's also very time consuming. So I'll just give a crux of it. So now the basic thing, if I talk about any operating system, the basic or the heart of operating system is kernel. What is kernel? Kernel, now I spoke a few minutes back that you being a user is trying to access any application. Application will pass the information to operating system. Operating system will take the information to hardware. Hardware take it back to operating system. Operating system will bring it back to application, and application will take it back to users. But some component in the operating system should take that responsibility to pass the information, to be a medium. That component is called kernel. Very, very important component of Linux operating system is kernel, and that is the reason it is said to be the heart of operating system. Now basically this kernel comes up with four very, very important aspects. So kernel, four important aspects or four important components of kernel, if I have to talk about, then the first important components important components or aspects of kernel is what? The first thing which kernel's very, very important aspect is device management. First one is it works on device management. Second one is it works on memory management. And this you will search any website, you will get it. It works on memory management. Third one, it works on management, process management. Fourth one, it works on handling all the system related calls. It works on handling system calls, all the system related calls, because of which this kernel is very, very important. There could be some other functionalities also, but these are the important aspects or important components of a kernel. Another important component of the architecture of Linux operating system is system library. You would like to have task performance. User wants to perform some task. Those tasks, those performance of tasks comes through system library only. Eventually everything has to go through kernels only, but all the tasks which user wants to perform goes through system library for its execution, for its application. Now, after system library, it comes another important component, which is compiler. Now, eventually consider that you are working on Java based application, Python based application. So these are applications should be compiled in the first place so that you can use it effectively. Compiler is very, very important, and quite similar to that, we have user process, we have system, we have software system also, which comprises of architecture of your Linux operating system. So I won't go much into in depth of architecture part. What we have learned till now, what is operating system, why Linux operating system only, And then we saw crux of architecture of Linux operating system. Under crux of architecture of Linux operating system, you got some idea about what is kernel, wherein you learned that kernel is the heart of operating system. It plays a vital role, and in order for it to implement that vital role, it takes care of device management, memory management, process management, and it handles all the system related calls. And after that it comes system library, which helps all the tasks to perform whatever task user wants to do. All those tasks has been cascaded, has been taken care by system libraries only. Other components like compilers, user process, softwares also makes a part of the architecture of Linux operating system. Now, after this, let's quickly talk about the fundamentals of shell scripting. We'll talk about shell scripting in my upcoming session. I've created a full-fledged video of shell scripting wherein I spent approximately 1.5 hours for to explain shell scripting. But today we'll see some basic or fundamentals of shell scripting, and not only the fundamentals of shell scripting, we will see some hands-on also. We'll execute some command and we will try to see all these components. But first, let's try to understand what is shell. Now, shell is a way to talk to an operating system. You got to know how we talk to how we being a user talk to an operating system. In order for us to talk to an operating system, we need a kernel. We need something called kernel. But in order for a user to talk to operating system or talk to machine, you need something, and that is called shell. Shell allows us to talk to an operating system. Now, for example, what you want to do? You want to create a file, you want to create a directory, or you want to create a folder. You want to create a folder. You want to list content of a directory or list content of a folder. You want to write in a file. You want to check for the system performance, right? You want to check for the system performance. Different things you prefer to do, right? Different things you prefer to do. Now, in order to prefer all these things, what you would like to do, you would like to perform certain some or the other activity. Unlike Windows, Linux is a bit different. We have seen in our previous day 5 session also, wherein I gave you a glimpse of Linux, wherein I said you that in Linux mostly we prefer to execute commands. In Windows it's very fancy. What you do in case of Windows, in Windows you go and click here and there, multiple options you choose from, you click here and there, and eventually what happens is you end up creating a directory or you end up creating a file. But it's much different in case of Linux. In Linux you don't have that graphical user interface as such. So how will you create? Let's see that in practicals. So in order to see that in practicals, I already have the Linux terminal open with me. It's quite in the same way. I've created it in the same way like the way explained in our previous session. So now in this terminal, what I'm going to do, I'm going to show you how to create or how to perform some of the commands, how to execute some of the commands of Linux. And let's see how that works basically, right? So how that works basically, let's try to understand that. Now consider that you want to create a file. Now the easy way to create a file in case of Windows is you just do a right click and then choose create file option and you end up creating a file. But that is not the thing. In case of Linux, that is, you can't work in that way. In case of Linux, in order to create a file, you execute some commands. For example, I execute ls and it's empty as of now. At this point of time, it does not have anything. Now, in order to create a file, I execute a command which is touch and give the name of file. For example, file1. And as I hit enter, it does not prompt me anything. But if I do a ls now, you see it created a file which is with the name file1. So touch command is used to create one file. But when you're creating a file, you will write something. Touch command creates one absolutely empty file for you. It does not have any content within it. How will you write in a file? How will you put some content in a file? So in order to put some content in a file, like the way when you have to write something in the file and when you are working in the Windows system, what you will do? You will use a notepad, some editor to write some content in the file. Similarly, in Linux, we have different kind of editor. We have nano editor, we have gedit editor, we have vi editor. Different types of editors are present in In case of Linux, the most simple to use editor is Nano Editor, which we use in Windows. Other commonly used editors are VI Editor, which I'll show you in our upcoming discussions also. So now let's try to write something by using Nano Editor. So if in order to use Nano Editor, I'll write Nano and I'll write file 1. So now you see one GNU Nano editor open. It clearly says, the interface says GNU Nano 7.2. This is the version for this editor. Now here it's quite similar to the notepad from this point of time. This is day 6 station, day 6 station on, right? This is, you can write anything here. I'm just writing something. You can write anything here. This is day 6 station on Linux and fundamentals, Linux and fundamentals of Linux shell commands, right? I can write anything. Like a notepad, you can write anything on this, like the vacancy I've written. Now, after you have written, you have to come out of this. In Windows, it's very easy. You click on the cross symbol and it asks you whether you want to save it or not. And you say yes or no, I want to save it, and you come out of this. Similarly, you see at the bottom, there is something to which we call as exit, right? At the bottom, you see there is something which says exit. I'm just highlighting it. So in order to exit, you press Control X, and then it says quite similar like the way it asks in Windows, yes or no. I say yes. And as I say yes and hit enter, I came out of it. So as simple as that, quite similar to Windows, but there is Control X to exit and Y as yes, and then hit enter to come out of it, and that's it. Now I've written something in the file. How can I see? Do I need to go again to Nano Editor to see what I've written in the file? No, there is an easy way to do that. Cat command lists the content of a file. So now as I hit enter with a cat command, so cat command is used to list the content of a file. This is day 6, quite the same thing which I wrote when I opened the file in Nano Editor, quite the same thing I can see here also. So what you have learned, how to create one empty file, how to write some content in the file by using Nano Editor, and how to list the content of a file. Now, what are the other things you do? When you talk about Windows, the other things which you do also is you create some folder. So now folder is known as directory. When I talk about in Linux terms, folder is called as directory. Now, how will you create a directory? In order to create a directory, the command is mkdir, and I'll say mkdir dir1, directory 1. Now I have created a directory also. Now how will you list things? In order to list things, the command which Linux offers, which is there in, which is commonly used in shell, is ls. Now you see dir1 is the directory 1, file 1 is the file. Now there is some color difference also, like the way you can see dir1 is is in different color and file 1 is in white color. So now how will you understand? Other than the color combination, it's okay. Now you will say, okay, fine, you have a black screen. That's the reason you are able to see this color difference. But what if you do have some other color of the screen? How will you see that? You will not be able to understand just like this way. In order to understand it in more detailed way, the command is ls-ltr. And now when I hit enter, you see for file 1 at the first place there is blank, but for dir1 D is written. So this D at the first place says, okay, I have created a directory, and the blank space for file 1 says it's a file. So now other usage of ls-ltr is it gives you more detailed information about your output. Now the first component talks about the permissions and the type of file it is. Second permission talks about the owner. Second, this component talks about the group owner. And after that, this component talks about size, and here the timestamp, date and time also. So yeah, it gives permission, permission, owner, group owner, size, and timestamp also. Such detailed information you get by using one single command ls-ltr component also. right? So these are some of the very commonly used commands. Some other components are also there, some other commands are there. So you have created a file. Normally what you do, these are the operations you will perform in a file system. You create a file, you create a folder, and you list down the content of a folder, you list down the content of a file. These are the commonly information. Other thing which you do is you try to delete the file also. So what are the commands to delete a file? Rm is the command normally. Rm is the command which we use to delete a file. So if I say rm file1, you see if I do a ls-ltr now, it has deleted the file. Now, how will you delete a directory? In order to delete a directory, the command is rm-r. And then you say dir1. And now if you list it, even the directory is deleted. So these are the commonly used commands which you normally use in Windows, and quite the same way you can use in Linux also. These are the commonly performed operations. Now, what are the other things we do in Linux side? We check on the performance side. So this is about the file system and folder system management. Another important component is the performance of your machine. How will you list down the performance of your machine? So say in case if I ask you to check for the performance or the CPU utilization in Windows, it's very easy. You will go to system properties, you will check for the RAM size, and you will check for the RAM size, and then you will compare the RAM size in task manager. And if the utilization is too high, then you will say, okay, fine, the performance is getting impacted. How will you do quite the same thing in case of Linux? If I have to do same thing in case of Linux, there are certain commands which we use. Free is the command. Like free is the command which tells me about, okay, fine, what is the memory usage at this point of time, and what is the memory utilization, total, used, free, shared. Different components are there as an output of free command. Now, in case if you want to see in more compact way, you can use the free, and you can use free with some flags -g also. Now, this gives you even better informations and output in a more compact and more organized way in a specific format. So yes, free command gives you the output of the memory usage and the utilization of memory of your machine. Another important command which we normally use, say for example, if I have to list down the CPU cores of my machine, then the command which I can execute to list down the CPU cores is nproc. So normally we execute this command. So now this is a very basic machine. I'd have launched a T2 micro machine. That is the reason the CPU core which is available for this machine, allocated to this machine, is only one. What are the other things we monitor? We monitor the file utilization. So df is the command which is used to list down the file utilization. If you want it in more human readable format, you put hyphen df, df hyphen h. df hyphen h is the command. It's in more human readable format. It gives you the detailed information in GB and MB format so that you can easily read it. But what if you want to list down everything? So you have free command, you have nproc command, free command to check for the memory, and proc command is to check for the CPU core, df for file utilization. But if you have to check, and this is very important interview question also, what is the command which will list down everything for you? Free, CPU cores, file utilization. What is the command which will do everything for you? So the command which does quite the same thing is top command. Top command is very important command in Linux, which tells about CPU utilization, which talks about the memory, which talks about various processes which is running in your machine at this point of time, uptime of your machine, how many users you do have in the machine. All the detailed information you can see by using your top command. So this is very important interview question. So you can use either ways. You can either execute top command to list down everything, or you can use separate commands for your performance management, for checking for the system utilization report. Okay, so this is all in my day 6 session. So I'll give a gist of what we have covered. We got to know about what is operating system, why Linux as an operating system, benefits of Linux operating system, life cycle of Linux communication process, and then we have seen architecture of Linux operating system. After that, we spoke about some fundamentals of shell commands, wherein we learned about file management. Under file management, we have seen how to create a file, how to write in a file, how to create a directory, how to list down the content of a file, how to list down the content of a directory. And then we have seen the system management or process management. In order to perform the process management, we have looked into the commands such as free command to check for the memory and proc command to check for CPU codes. And then we have seen the cumulative command, which is called top. Okay, so this is all about today's session. In my tomorrow's session, I'll talk it in more detailed way. I'll talk about shell scripting. A full-fledged session will be there, which is will be on shell scripting, wherein everything which you need to know about shell scripting will be present. I thank everyone for watching this video, and certainly share this video to anyone whom you think could get benefited by watching this video, and certainly subscribe in case if you did not. Thank you.